All right, so you guys were supposed to do all of the circle problems, right? Circle problems.
Triangle.
Triangle, circle, nice. You are correct. It is a triangle. Okay? So, triangle problems. Let's see. All right, triangle problems, right? So, first page of triangle problems is this one, right? So, number 2, you were supposed to just find a slope and use y equals mx plus b. 6 and 7. 6 was what? Perimeter. And, no, sorry, 7 was perimeter. 6 was volume. Any issues on that page? So I hope you guys understand that, like, why I didn't show you tons, because there's tons of applications, right? But, again, geometry ones you should have been okay on. Elle, we got these out? So then look at Canvas. Yeah, look at Canvas. So anything 2, 6, 7. All right, so then next page, 8. 8 was another y equals mx plus b1. So you might not have matched an answer exactly because you could have used 2 different points. All right, so again, you should have been close enough to that equation, right? Close enough to that equation. Then if you go to the next one, right? The next one, the next 3 were more geometry ones. So, I'm sorry, 13. I'm going to go back to 13. 14 was area. 15 was what? Volume. And 16 was also volume. So you didn't have any on that page. I just skipped over a page. Right? 13 I'll go back to. 14 was geometry. 15 and 16 geometry. Any questions up to 16? Again, besides 13. Anything up to 16 that you want to look at? Okay, back to 13. 13 is really the only one that I don't think was, like a formula that you would definitely know and plug into, right? So 13 is a direct variation problem. So we really have 2 types of actually 3 types of variation problems that you can have. We have a direct variation versus an inverse or indirect variation. So they're really easy. A varies directly with B means that I have to have some constant K that relates them. So like if you have a job, your paycheck would be directly related to how many hours you work, right? And the constant of variation would be how much you make per hour, right? So paycheck is an example of direct variation. Inverse variation is a problem like A equals K over B. So direct variation goes in the same level, I guess, right? So both numerator. Inverse variation would go in the denominator. So on this one, if I use this idea right here, 2 ways you could solve the problem. I like to solve it for K. So I'll say A over B is K. And I'll do each situation. So let's see what it says. It says, all right, the diameter varies directly with the square of the velocity. So there always has to be this constant of variation, K. So I would take that and I would use that formula and I would say, okay, diameter. I would say D over V squared equals K. So you could solve for K, plug it back in, but I like to just do left and right. So it says when the diameter is 0.2, the velocity is 2, And that has to be equivalent to, when the diameter is 0.5, what's the velocity? So you just cross multiply and solve. So 13 was kind of the only one in that first set that I think we really kind of didn't look at. Anything else up to 14 that you want to look at? Actually, no. Yeah, 14. Sorry, I'm going backwards. 16 that you want to look at. Anything up to 16?
Can you do
14? Sure. So 14. The way they did 14, I think I would set it up a little differently, right? So the person that made these worksheets, I took their answer key and I linked it. So I'll show you the difference between the two. So let's see. Ryan has 3,000 feet of fencing. River is one side. You use all the fencing. So the way they set it up, they did I was right the first time? Okay, they did Y and Y, and then they did X. So they solved for Y by saying what I have minus what I used divided by 2, because there's 2 sides left over. So that's what they got per dimension. I personally wouldn't do that. I would say this is the one I'm going to keep. This is the one I'm going to solve for. What I have minus what I used, and I don't have to do it divided by 2. So that's how I'd set it up, right? So I'd keep this, and I'd make this what I have minus what I used. So then the area would be X times 3,000 minus 2X. It's an upside down parabola. And I should be writing on here because I'm recording it for the people that are absent. Alright, so I should be writing on here. Which one is this one? 14. Alright, so my equation is this. I can easily know what that looks like. Y-intercept at 0. Y-intercept at 1,500. Upside down parabola. So we had to find the maximum. So I know exactly where the maximum is going to occur. It's going to occur halfway between them. So this is 750, right? That's 750. And then you could use your graphic utility and just take the y out and get the area. Is that okay, Austin? So I like solving it the way I did my picture, right? I like going x, what I have, minus what I used for the dimension. I guess the domain would just change differently in those two problems. The domain on this one would be up to 1,500. Anything else up to 16 that you want to look at? All right, then there was like the second set of problems, right? And there were a couple of triangle ones. All right, triangle. Which ones were triangle ones? Let's see. So triangle was 3, right? So that was a right circular cylinder, volume. 6, average cost. So you're just taking the cost and dividing it by how many items. And then 11, another average cost. I think that was it, right? Yep. So any of those last 3 or 4 triangles that you'd like to do? Any more of those 3 or 4 triangle problems? 11, yeah. 11. All right, so I think 11 was really just a problem with the picture, okay? So it says we have a cost, and I need to find the average cost. So I need to take this function, 0.001 x cubed, and so forth, right? and find the average cost by dividing it by the sugar cane, right? So dividing it by x. I think the answer key showed, right? They simplified it. This over x is x squared. X. No x, and then a fraction. So what is the average cost of producing 100? We would take 100 and we would plug it in. Get an answer. Do that in a second. Okay? Using graphing utility, get a graph. I'll do that in a second. Find the number of pounds of sugarcane that should be produced to minimize the average cost, and what is the average cost? So I'll go to Desmos, and I'll put that function in. Okay? So the function is f of x equals 0.001 x cubed minus 0.12 x squared, and I'm going to keep on going, 6x plus 250, all divided by x. Okay, so that's our equation. We need to find a minimum. So it's all about just looking at the window correctly. I need to find a minimum. So I can tell there's a minimum in that picture, above, right? So the minimum would be, again, hoping I'm pressing on the minimum. When I press on any point, it doesn't really create the point. So that minimum is at 79.686 and 5.929. So what that means is that's the number of sugar cane. That's what the cost per sugar cane, right? That's what that would indicate. So that is C and D, and then E as well. Average cost is 5.925. Is that okay? And then I guess on B, find it for 100. I could just go F of 100, and I get 6.5. Any other ones that you guys would like to look at? You all set? Okay. Sure. Number 3. The oil tank one? Is that the right number 3 one? Okay, so oil tank one. Alright, so an oil tank is in the shape of a right circular cylinder, has a volume of 55. So again, we talked about work on our last assessment. As you're reading the word file, you highlight stuff, you underline stuff, you write stuff down that's important. Right? And it's a right circular cylinder, so I'm going to remind myself by drawing a little circle. Write an equation in terms of the radius that represents the surface area. Note that the tank will have both a top and a bottom to seal it. Okay? So maybe you don't remember surface area of a cylinder. If you do think of the wraparound and you cut it, that's just a rectangle, right? So that would be what? The length of the rectangle would be the circumference, so 2 pi r. And I'd want to go multiply it by the height. And then I'd have to add 2 circles, so 2 pi r squared, right? So that would be surface area of the cylinder, and it does say top and bottom. Okay, so then volume. Volume is area of the base, pi r squared, times the height, times h. We know the volume to be 55. So I can plug that in. So I have this equation, and I have this equation. So it says, write an equation in terms of r. So this has r and an h. This has r and an h. Solve this for, and I'm just looking at, solve it for h. So h would equal 55 pi r squared. We're going to take it, We're going to plug it into H. So surface area is 2 pi r H plus 2 pi r squared. So an r would cancel. And I'm left with, oh, pi would cancel too, right? So I'm left with 110 over r plus 2 pi r squared. Is that okay? All right, so it's just realizing which formula is easiest to solve which letter form. Anything else?
I'm not sure if it means when it says like an equation in terms of r.
That means just no h. So this one has it in terms of r and h. So no h, just r. Just r. Mm-hmm.
So I know we're supposed to round everything to like 3 decimals, but if we're talking about cost, should we round it to 2 decimals?
No, still do 3. Yeah, still do 3. I just want you to stay in the habit of 3. Right? We realize it's money, so it should be 2, but let's stay with 3. Okay? Any other ones that you'd like to look at? Okay, so since we have this out, let's just peek at it for the problems that you guys are going to have to do for, what would that be, Tuesday? Okay, so we have the circle problems. So a lot of the circle problems are regression. So you're not completing these now, right? You will have time at the end to start them. So if we look, number 10. Number 10 is a regression. And I told you linear regression. Number 11 is another regression. Number 12 is another regression. Look at number 12 for a second, though. Right? Look at number 12. On number 10, 11, and 12, they use years. So there's kind of 2 ways that you could use years. So on number 12, you could use 1998 as the x. You could use 2000 as the x. That's the preferred way that I like to do it. So that's what I want you to do on 10 and 11. I want you to use 2010, 2011, 2012. On number 12, I want you to change it a little bit. I want you to use time starting at 1998 is time 0. So in the chart, if you notice on 12, see how I put t being 0? So then 2000 is t being what? 2, and so forth. So that's how I just want you to do 12. I want you to change it in that manner. Next one after that is 17. It's asking you for a linear regression and a quadratic regression. 18 is asking you for a quartic regression. 19, corner of the box. We did one like that. 20, I think, is a piecewise function. 21, quadratic regression. I think there's only a couple more. 7 is our volume. 8 is an average cost one. No, 8 you were given the equation for. And 9 is a selling one. Okay? So anything that is circled is for next class. Put those away right now. You are going to have time to work on them at the end. But I want you guys to have a calculator first. So a graphing calculator. If you don't have one, you are going to come up and grab one. If I need more, I'll go grab some. Alright, so let's kind of review where we left off yesterday. I'm pretty sure we talked about all of these regressions. And then didn't we do a table of values for number of diagonals? Is that where we ended, right? So I had the number of diagonals up there earlier, right? And we'll write it again. So it was number of sides and number of diagonals. So what did we go up to? 8, I want to say? 3, 4, 5, 6, 7, 8. So, oh no, we didn't do 3, right? We started at 4. So that one was 2, that one was 5, 9, 14, and 20, right? Did we even start it in the calculator yet? We did? Okay, different classes I ended on different parts. Did we do linear regression and quadratic regression on it? Just linear. Okay, so let's kind of recap, right? So we got this set of data. We said that it is not linear because the average rate of change is not constant, right? So the average rate of change of the average rate of change is constant. So I really know that it is a quadratic function. So let's just start from the beginning. Okay, so if, again, you guys are on the graphic calculator right now. So Chromebook's closed. So let's just check it again and let's go get that linear regression. So make sure you have nothing in your y equals. Yesterday, I think we had to turn on the correlation coefficient. So let's hit mode, and again, you guys are going to make sure you tell me if any of your calculators do not have exactly what I have on it. And remember, I don't know how to really use the Casio. So if you want a TI one, again, there's more up there on the TI one, right? And Savannah's is the different one. All right, so your static diagnostics need to be on. That gives you your correlation coefficient. Do you have it on yours or not? I don't think you do. So it's really easy. You just going to go highlight. Once you turn it on, though, then I'm going to go off. I'm going to go with the diagnostic on. And now yours will be on. Okay, so you need stat diagnostics on. Okay, so let's make sure your data is still in there. Okay, and I have some notes over here from last class, right? So if you need to take a picture of this later or write it down, that's what you're going to do. So to put your info in, we're going stat edit. So stat edit. You can see in the other class, we also did it for a nonagon, 9 sides. So why don't you guys go add that last piece? Add 9 in there. So you go in 4, 5, 6, 7, 8, 9, and then you go in 2, 5, 9, 14, 20, and 27. Let's do it. Here. Stat edit. Does that one not work right now? Battery. Just got the other one. Yep. Stat edit. So make sure you have those pieces in there. Okay, first thing I want you to do is I want us to get a scatter plot. So to get a scatter plot, first thing we need to do is we need to look at the window. So our window needs to have all of those numbers in it. 0 to 10. 0 to 30 maybe would be good. So you're going to hit window, 0 to 10, 0 to 30. You're going to turn your stat plot on. You do it by going second, y equals. Second, y equals, and my plot one is off. So we're going to hit enter. We're going to turn it on. Remember, scatter plot, line plot, bar chart, box and whisker. L1, L2. I like the bottom, I like the open square, and it doesn't matter the colors. Go hit graph, and that's what it should look like. make sure yours looks like your partner's. So share the calculator with each other, make sure they look the same. I'm going to go grab All right, does anybody have an issue with that? Any issues? All right, so now we're going to go do that linear regression. It's going to be a little different than yesterday because we put another point in. Okay, so you're going to go stat calc. You're going to choose your regression. So stat calc. And we want number 4, a linear regression. And Savannah, yours is different, right? You're still going to do that. But then you're going to go L1, comma, L2, comma, Y1. So X's are in L1. Y's are in L2 to store your regression equation. That's why I have alpha trace there. That's it. What's on the card? Yeah. But you have to go to the regression now. You got to go stat, calc, lin res. And that's when you have to go L1, comma, L2, comma, Y1, bars, Y bars, okay? So to get Y1, you're going alpha trace, and you're getting Y1. Go and hit calculate. This is what you should get. And everybody should get exactly what I have. Okay? Do you guys have exactly that? Exactly that. If you don't, then I'm going to say look at your tables first and make sure your tables are in there correctly. So let's try it, right? If I try this equation, y equals 5x minus, what's that, 19 2/3, right? If I plug in 8, does it get me the answer? 5 times 8 is 40. 40 minus 19 2/3 is what? 20 1/3? It's supposed to be 20, so it's pretty close, right? That R right there, the bottom R, 0.989. Does anybody take stats this year? Okay, what's the R, Kyle?
It's the correlation coefficient.
Very good. Correlation coefficient. You want to explain what it means?
It means how accurate your line of best fit is. So if it's closer to 1, it shows a strong positive correlation. And if it's close to -1, it shows a strong negative correlation.
Okay. So in terms of what we're doing, line positive, line negative would have a negative slope, right? So really close to 1, or actually being 1, is a perfect fit. That means all the points are on the line, right? Really, really close to, I'll say, the absolute value of 1 is a really, really strong relationship. That means the points are really, really close to the line. A 0 would be a no fit. It's just like a big blob. Now, someone in the other class asked, how about R squared? R squared?
It's like variation. It's like how much.
Correlation of determination?
Yeah. You can tell us that.
Okay, it is. It's correlation of determination. Keep on going. See if you can explain it.
It's 97.91% of the variation in the number of sides of a polygon can be expressed with the linear regression with
So, most of the polygons, right? 97 point whatever, or no, yeah, 97.9, right? Can be using this linear regression as a model, right? Right? But actually, this model is actually kind of bad, right? It's good for these points that we have. But when we try and go to predict for 100, So if I go second window and I put my table start at 100, I just don't want to hit the down arrow or up arrow. And then I go to my table, it's predicting for a 100-sided polygon that I have 480 1/3 diagonals. You're going to see that that is actually way off. It's like 4,000 something. Okay? So let's go do the better regression model. We know it's quadratic, right? We said that yesterday because the average rate of change of the average rate of change is constant. So I want you to do the same thing, and I want you to do a quadratic regression. So hit second mode. Second mode. We're going to go do a quadratic regression. Stat. Calc. Quadratic regression. So that's number 4. 5, thank you. You're going to do the same thing. L1, L2. You're going to store the regression equation. Let's use y2 this time, right? Because we already used y1. So we're going to go alpha trace y2, right? y2. Go down and calculate. The purpose of cutting and pasting it in there is so that I can make a prediction. They don't give an R in this one, because an R is really for a linear regression, but they give an R squared. So that's saying 100% of the polygons can use this model. That means it's a perfect fit. Okay? So a regression is the best equation. It's got a perfect fit. So now look, if I go second graph and go to table, look how many diagonals there are. 4,850. Right? And that's correct. Right? So that is way off for linear. But hopefully you think, right? If I have, I'll actually just use my picture, right? If I just have my graph, when you look at the red versus the blue, the red's the quadratic, aren't they just going to get farther and farther apart as we keep on going higher and higher, right? So quadratic is the best fit. Linear, it's good for these 6 points, but as we get higher, it's going to be way, way off. Okay? This is one place where, yes, I like Desmos better. Okay? Desmos, it took us what, 10, 15 minutes the other class, 10, 15 minutes today to go on our calculator. Desmos is a lot better for regression. Okay? So let's go to Desmos. Alright, so everybody's got to get Desmos now. Everybody get Desmos.
Can we use our phones?
No, use your Chromebooks, that's fine. Actually, you know what? Let's try, you're supposed to have the test mode on your Chromebooks right now. So let's look and see if we have it. No, you might.
No,
I know the
it
trick
wouldn't
to
let
do it.
It wouldn't let my microphone down like that.
Oh, it wouldn't, so I know your Chromebook has it. Do you have a Chromebook too?
I actually do have that.
Yeah.
I usually don't.
When I turn my computer off,
Say it again?
when I turn my computer off.
Yeah, so if you all power down and power back up and don't sign in. Power down, power back up, don't sign in. Okay, just power down, power up, don't sign in. Go to apps. Right, so I tried it a different way with someone else, so that's why I kind of want to look. If you go to apps, it should have Desmos test mode, right? Open it up. It should say start test. Gives that little green banner, right? So after we use it, we'll shut it down and make sure it shows you that time, okay? So if you're using Desmos on the, again, I don't really want you using Desmos if you're graphing stuff. If you're just doing regular calculations, I think it takes so much longer in Desmos than a regular calculator, okay? So we're only going to use Desmos when we're graphing stuff. If you need a regular calculator, invest in a $10 scientific calculator. I just looked the other day. Someone said they wanted to buy a TI to get used to it. I looked on Facebook Marketplace. There was one for 35 bucks. Right? Don't get, sorry, some MSC. Don't get this model, the 83, because that's the old operating system. Again, we know how to work it, right? You're going to get this model or this model, which are both 84s. That's the one that it still works, Savannah, right? You just have to do a little extra something. Okay? No worries. Yes, it does. All right, so everybody's got Desmos up there. The reason I like doing it this way rather than another way, Charlie, did you not restart your computer?
Oh, from my tabs.
Drive me crazy. Oh, I was just going to say, don't though. Did anybody not restart it? Okay. The reason I like doing it that way rather than doing it the other way is it uses your whole screen. The other way you can do it. So, Thea, you might want to try this on your MacBook. Turn off your Wi-Fi. And if you turn off your Wi-Fi, it does allow it to be test mode, but it's only like this wide. It's just like the phone one, how it's so small, right? But try that on your MacBook. It might work, right? And if Thea's works, we'll show you how big it is. Just turn off your Wi-Fi. Now, oh, that's what you did downloading it from the Chromebook. So just try regular Desmos. Try regular Desmos and turn off your Wi-Fi. Okay. All right. So let's do regression on here. Right? Let's do our regression on here. So you're going to go add a table. And I'm going to show you a couple of things. So let's go put our table in there. Right? 4, 5, 6, 7, 8, 9. Oops, I don't want 10. So what were our numbers? Our numbers were 2, 5. Thank you. Keep on going.
14, 20, and 27.
Okay. So we have our table in there. So what you're going to do is you're going to fix your screen to see your points. There are my points. What you're going to do is on this little left-hand side, if you just click it, it automatically does a drop-down for regressions. So look, that's exactly what we got. 5x minus 19 2/3. Right? It gives you your R. Again, pretty good correlation coefficient. Do the drop down, do quadratic regression. It gives you the exact equation. So yes, I like Desmos better with regressions. You're not going to hear me say that a ton, right? But with regressions, totally. Now for prediction, 2 ways you can do it. Someone in the other class told me this. I didn't know this. That if you just hit this little equation thing right here, it takes the equation and cuts and pastes it again. Okay, I didn't know that. If you go and you change that y to an f of x, and then you go say you want f of 100, that's how you can predict 4,850. There's another way you can predict. If you take this equation, cut and paste it, and put it in your table right here, right there, you put it in your table, you go to the x, and you take the little 1 out, so you just make it x. To me, this isn't worth it. And then in your table, you go hit 100, it will give you prediction there. I like hitting the equation, changing it to f of x, f of 100. Okay? It just means x sub 1. So the first equation that we're looking at, if we did another table, I would think it would have x2 on it, right? So a second equation, I don't know, let's try. if we do a second equation, oh, it's because I already took out x1 maybe, right? Oh, so I don't want the f. Let me try it and leave it in there. Right, so if I do another one, yep, so see, it's just table 1, table 2. Regression easier than on your calculator? Yes. Right, why is it? Okay. But not on all things, Charlie, sir. All right, any questions on regression, correlation coefficient, any of the word problems that we did? Okay, so what I want you guys to work on in your groups is I want you to work on the non-regression problems, right? Because there's a lot of regression ones on here. So what are we doing? Circle now, right? So I want you working on starting at number 19, 20, 21 through the end. Okay? So together, I want you trying the non-regression ones, right? So I'm just looking at Desmos too, right? And you turn it off, and we got 6 minutes. So that is what we're going to use for test mode when we're using Desmos. Okay? So again, you don't sign in, and you go right to the apps, and it does test mode for you. Okay? All right, so everyone is working on the same ones. What did I say? Starting at 19 or so. The non-regression equation. I don't give you a ton of time to do homework in class. You got like 15 good minutes here. So make sure you're all working on what you're supposed to be working on. If you borrowed a calculator and you're going to use Desmos, then just please return the calculator in my drawer, please.